Hey guys, welcome back to another tutorial on fuzzy sets. In this video I'm going to show you how to compute two important fuzzy operations, that is algebraic product and bounded difference, using Python with a clean object oriented approach. Alright, so in algebraic product we have two given sets right here, and for each membership value corresponding to its element we take every single index and we multiply both the membership values for each set, right? So that means we have 0.7 into 0.5, which is 0.35. Like that, we do that for each set for both the elements corresponding to that index, right, in x2 as well as x3, and we get the result. We set them up in a dictionary right here and we call it algebraic product. And in bounded difference we have, by the formula max, you take either maximum, the value that you get from the result, or you take max 0. That is, if this is a negative integer, then it will take a max of 0. We cannot go beyond 0, as in we cannot go towards negative numbers, right? So we calculate this in a way where mu a minus mu b, that is for each index of set A and set B, is calculated finding the difference. So we have here 0.7 minus 0.4, which will be 0.3. So since 0.3 is greater than 0, we will take the max of that number, which is 0.3, and we set them up in the first index. X1 will be 0.3 in the resultant set, right? Or in this case resultant dictionary. And in the second index we have 0.5 minus 0.6, which is a negative integer, which is 0 minus 0.1. So right here, since we are having a negative integer, we will take a maximum of 0, so we set that x2 as 0, and it goes on, right? So moving on to the program right here, I can say that we have two segments. One is a class algebraic bounded product, and one is a dunder method, the main method where the operation starts. So I would recommend, before we come to this video, that you check out the previous videos that I have where I have explained the user input for each set and how we check into create fuzzy set, the exact procedure for this, and the instructions given to enter every single set. So before we move on to what algebraic product and product differences, I recommend you watch that again. And right here we have, right, so we are taking the other set, which is algebraic, which is of type algebraic bounded product, right? Because we are passing fs2 here, the second fuzzy set, and fs1 is the first fuzzy set. So when you're calling algebraic product, we are passing fs2 right here as the other set, and since we have access to the other set, we just calculated using other.fuzzy dictionary items. And items method basically accesses or gives us access to both keys and values to that fuzzy dictionary. And in these two for loops we basically have access to the keys and values of both dictionaries, that is the set A and set B as well. And we check if set A, if the key in set A and the keys in set B match, that means that if x1, right, and x1 right here in both the sets match, only then we will continue with the calculation that we are taking A value and the B value, that is the membership values of each index, that is 0.7 and 0.5, and we are calculating them, multiplying them, and this is the format specifier where it calculates nearest to the second digit, two digits. So it will give us something like 0.35, if I'm right. Maximum, it will not go beyond 0.350 or something. It won't be beyond that. So, and the value that we get, we insert them into the key of the resultant set, right, as a membership value. So like that it keeps going on until we have the resultant set. So in bounded difference right here, we access the same through double nested for loops. So basically it means that we first access the first set A, right? That is for x1, uh, x2 and x3 in set A, right? And now when we go on to the second loop, we have access to the second set, the keys and the values in the second set. So when we have access to the keys and values of the second set, we can check that since a key, which is at present x1, and sorry, x1, that is a key right here, and b key. So b key at present will be x1 as well. It will calculate the maximum value, say that this is the difference, and it will calculate the maximum value, insert it, and we store them in the resultant dictionary. So when we have the maximum value, that is comparing 0 and the maximum difference that we have using a val minus b val, that is when we get the difference of 0.7 minus 0.4, we calculate which one's higher, we take that value and insert it as a membership value corresponding to that key and into the resultant dictionary. Now here we have b key, and I think in algebraic product we have a key right here. So it doesn't really matter what you put here, a key or b key, because we are checking right here that both are the same, and if only they are the same, then only we can carry on with this instruction to execute the statement, right? Otherwise it will not get into this statement. So if you put a key right here, it'll still give you the same value, right? The resultant value. So right here, when b key gets into the second iteration, we have b key as x2 and a key still on x1, because we are still continuing with a key as the first iteration. So when we have b key and b value as x2 and 0.6, that time it will check whether a key, which is x1, and b key, which is x2, are they the same or not. So since it's not the same, it will go to the next iteration of b key and check for x3. Is x1 equal to x3? It will not be equal, so it gets back into the first loop again, right? Then a key becomes x2, and then we check for the first iteration of b key, that is x1, is x2 for set A and x1 for b key, that is set B, are they the same? They will not be the same, so b key becomes x2, and then a key becomes x. Since this, we have a key is the second iteration and second element, that is x2, will it be equal to the x2, the second iteration of b key? It will be the same, so only then it will calculate the result. So like that the loop goes on, and this one runs 3 times, and this one runs 3 times for each time the set A runs, right? So like that we compare, we find out if the keys are equal, only then we carry on with the result. And when we have the dictionary, that is finding the difference between this and 0, we take the maximum value of whatever the difference is. If it is a negative integer, then we take maximum as 0, otherwise we take the maximum which is greater than 0. So what you saw here today is not just basic Python, this is the very foundation of how uncertainty is modeled in real systems. The algebraic product gives you a strict intersection where uncertainty compounds, and this bounded difference enforces a controlled subtraction, ensuring results never go below 0, right? So if you're serious about mastering fuzzy logic, soft computing, or even AI related mathematical modeling, this is the level you need to operate at. I hope you found this useful, because I'll be breaking down more of these concepts into practical code. So if you have any questions, please don't hesitate to drop them in the comments. I respond to all serious queries, and I'll see you in the next one.